There's something very strange about this thing, like it belongs in a cyberpunk movie. Blade Runner, perhaps? A prop to set the style of Tyrell Corporation offices with no observable function. But it does have a function. It's the Seiko Pyramid speaking clock. Granted, you can only tell that by looking at its underside. See? Display, controls, battery compartment. All completely invisible as it sits on the table. It does have a chrome top and slats, but I'll demo those in a few moments. Thing is, I don't have one of these clocks. I have 3. Black, gold, and silver, all colorways of the original 1984 release. I built this mini collection because completism is a sickness. If I learned anything from Adam Savage, it's that collections need display cases. Before I show you that though, here's how these actually tell the time. The chrome tip of the pyramid acts as a switch, and the synthesized speech comes through the slats under it. All together now.
9:01 p.m.
I know it sounds awful, but what do you expect from the world's first speaking clock? The display case build process started with walnut veneered 1/8" plywood on the laser cutter. It's a simple design meant to cradle each pyramid. I used the laser cutter to cut out a layer of 1/8" plywood for the underlying support as well, and a thin frame of frosted acrylic to surround both of those. Having exhausted what I could do digitally, I turned to more analog woodworking. Not acoustic though. After milling a walnut board into square, I cut it to length on the miter saw and then into thinner strips on the table saw. Set the table saw blade to 60 degrees to match the angle of the pyramid, and set about cutting long beveled edges on the walnut strips. Back on the miter saw, I cut 45-degree miters on the ends of the strips. Once joined, they should look something like this. And here's an early look at roughly what I'm building. Base layers and acrylic surrounds, still covered in protective tape, are to be enclosed in the beveled walnut frame. Oh, and off camera I cut rabbits into the inner parts of the walnut frame. It was a sketchy cut, so it's better you didn't actually see it. Back at my desk, I started on the glue up. First, the walnut plywood and the underlying base. I applied Type Bond 3 glue and spread it very thinly to minimize squeeze out. These two pieces needed to act as one, with the openings actually cradling the pyramids. The squares were cut a few millimeters larger than the pyramid bottoms to allow for a snug fit once the lining was applied. Lining? Yes, but more on that later. Although blue tape would do an okay job, I had a covering layer and some clamps. with the clamps and tape. Eventually, I was left with a neat plywood sandwich. Of course, I immediately started applying blue tape again. This time it was to protect the insides of the cradles. I was about to apply a spray lacquer finish to the walnut plywood and wanted to make sure the plywood in the squares remains unfinished. The camera didn't really pick up the finish of the walnut plywood for reasons, I presume. But with that step done and the tape removed once again, it was time to move on to flocking. That's the application of superfine synthetic fibers onto the raw plywood. First, a thin layer of adhesive is applied to the surface, and the fibers are forced out of the applicator tube onto the piece. There are plenty of dedicated flocking tutorials out there, so I'll just share one tip. Do not use a plastic bag in absence of paper or cardboard. If you do, don't expect to recover all of the fibers. After removing protective tape for the nth but not final time, the flocked cradles can finally be seen. Despite my complaining, flocking does produce a very satisfying and elegant lining or cover. Finally, I glued up the frame of the display case. Type on 3 and the blue tape, or once again, my weapons of choice. Because miters aren't the strongest joint, once the glue dried, I decided to reinforce them with dowels from the underside of the frame. I drilled to make some holes, glue and dowels, lightly tapped into the new openings, and flush cut to the frame with a thin hobby saw. I didn't actually do the cleanest of jobs here, but it's a valid approach to reinforcing frames, and if you do it right, the dowels can actually add a decorative element. The dowels in the entire frame need a touch up with some 320 sandpaper. Then the glue up was next, this time joining the frosted acrylic surround with the flocked plywood sandwich. I used super glue, which is known to cause haze when applied to acrylic. But since the acrylic was meant to be a light diffuser anyway, I was okay with that risk. Speaking of light, this is yet another layer which will hold up a chip-on-board flexible LED strip with an adhesive back. I'll mark the layout, drill a hole to allow the LED strip to pass through, and wrangle the strip into position. The corner bends are far from ideal, but the strip simply didn't have the convenient cut points to use 90-degree connectors. The power lead end of the strip goes under the plywood layer and eventually out the side of the case. Putting the assembled layers together, you can finally see what I'm going for. Sort of. I chose to screw the layers together rather than use glue, just in case I have to replace the light strip at some point. Put the assembly into the walnut frame that I finished with spray lacquer off screen. Test the light again, and not bad. I used a Dremel with a carving bit to create a channel for the power lead. And even though the assembly has a very snug fit into the frame, I decided I didn't want to rely on friction alone. I brought out my point driver. It's a unitasker tool which is great when building picture frames and weird Seiko clock display stands apparently. I drove in 4 points to retain the plywood assembly. Applied hot glue to keep the power lead in place, and not done yet. I grabbed an SVG file of the Seiko logo off Wikipedia and cut it out on a vinyl cutter. The idea is to stack a couple of vinyl layers to create a knockoff Seiko badge. The letters were cut out using white vinyl. I used vinyl in a handful of what felt were period appropriate colors as the backing. Also necessary was vinyl transfer tape to lift the lettering and transfer it onto the backing. I gently weeded the letters. Applied the transfer tape. And finally and carefully stuck the letters to the backing vinyl. After ensuring that the transfer was successful, I peeled off the transfer tape to reveal the final design. Well, 4 final designs. I chose the top 3 contenders and tried for a touch of fancy. I decided to dome the badges with UV cured resin. This would provide some protection to the badge, which is really more of a sticker at this point. But more importantly, it would give a 3-dimensional look similar to what you see on commercial products. Because this resin is viscous, it stayed on the vinyl and didn't spill over. I did encourage it to move all the way to the edge of the badge using the tip of the blade. Once happy with the distribution of the resin, I used the UV light to cure it. These close-ups show how much height and depth the resin dome adds to the badge. You can also see that the heat generated during curing caused the sticker to curl up. It's not a big deal, but something to consider when making these. I decided that the badge and flocking colors should match, so I applied the green sticker to the case. It was time to finally see how this looks fully assembled. The clear cover came from a car model display case I found on Amazon, and which effectively determined the dimensions of this entire project. And here it is. First during the day. and at night. If you happen to still be watching, thank you. There's actually a fourth member to this family. This is the first pyramid clock I got, but its components were completely shot due to battery corrosion. I still have the original PCB and wanted to show you my favorite part of the design. Printed on the board, which is still labeled as made by Seiko in the 1980s, is that this clock contains no 0 joules, and that it was unadjusted. I suppose quartz clocks were still a new enough invention to warrant this notice. Because the PCB was beyond my ability to repair, I decided to repurpose the housing as a speaker of sorts. The bottom cover, which I also cut out in the laser, can be removed to reveal a tiny MP3 board module I found on Amazon. It came with a battery, speaker, and switch that I routed into the tip of the pyramid. And even though it can only hold 8 megabytes of music, there was never any doubt which pyramid-themed band I was going to use to demo this. The weird light effect was completely unintentional here, but anyway, please enjoy this, the KLF, in their final form.